The SAID-4 Driller test suite contains synthetic code examples with its vulnerabilities from 118 different common weakness enumeration classes and was originally designed to explore the performance of static and dynamic analyzers. While the SAID-4 dataset provides labeled examples of many types of vulnerabilities, it is made up of synthetic code snippets that do not sufficiently cover the space of natural code to provide an appropriate training set alone. To provide a vast dataset of natural code or to augment the SAID-4 data, we mined large numbers of functions from Debian packages and public Git repositories. The Debian package releases provide a selection of very well managed and cured code which is in use of many systems today. The GitHub dataset provides a large quantity and wider variety of code. Since the open source functions from Debian and GitHub are not labeled, we used a suite of static analysis tools to generate labels. Details of the label generation are explained in subsection 3c. Vulnerabilities in software are typically reported to the Common Vulnerabilities and Exposures database once they have been identified and analyzed by security researchers. The CVE is a public repository of standardized information about cybersecurity vulnerabilities and exposures. Security vulnerabilities in software can result in disastrous effects because they can be exploited by attackers to gain unauthorized access, steal data, install malware, or cause system damage. These vulnerabilities can lead to serious consequences such as financial loss, reputational damage, or even harm to human lives in the case of critical infrastructure or medical systems. Large amounts of open source code are available for learning the patterns of software vulnerabilities on platforms like GitHub, which hosts millions of repositories containing various open source software projects. By analyzing this code, researchers can identify common vulnerabilities and develop tools for detecting and mitigating them. Traditional tools for program analysis are limited in the detection of vulnerabilities because they typically rely on manually defined rules or signatures to identify known vulnerabilities. However, new vulnerabilities can emerge at any time, making it difficult for these tools to keep up with the evolving threat landscape. Moreover, these tools may miss vulnerabilities that are hidden or obfuscated within the code. The researchers generated useful features from the raw source code of each function by using a technique called static analysis. They analyze the code at the elements, the number of loops, and the number of conditional statements. These features were then used to train machine learning models for vulnerability detection.